So what's the next step?
Factoring it.
Yep. What two numbers multiply together to get 18, but add together to get
6 and 3.
Equals 0. So x plus 6 equals 0, or x plus 3 equals 0. So x is equal to negative 6, or x is equal to, write it as negative 3 comma negative 6. Done.
I have number 18. Wait, so you always just
I just like putting them in lowest to least to greatest is helpful. Okay, another one.
18.
This was 9. Number 18. Thank you. Number 18. So what's that first thing you have to ask yourself when you're attacking these? So when you look at this one, is it in standard form? So you have to put it into standard form. What is standard form? ax squared plus
C equals 0.
Correct. So you actually need to do these out. So you end up with 3x squared minus 9x plus x minus 3 is equal to 2 plus 3x plus 15. What did I do there?
No, I know you did. It's just you.
I know. I'm pausing right here. I was just going to do it out. Yeah, I can combine the like terms. So you get 3x squared minus 8x minus 3 is equal to what? 17 plus 3x? Is that in standard form? No. So I'm gonna how about subtract 3x from both sides, end up with 3x squared minus 11x minus 3 is equal to 17. Now what do I subtract?
17.
So you end up with 3x squared minus 11x minus 20 equals what? 0. Is this in standard form? Yes. So step 1 is done. You now have it in standard form, which is nice. What's step 2? Yeah. This number is not what? It's not 1, which you like, but it's not that bad because it only breaks into 3x and x. Now you need to test numbers that multiply together to get what? 20. Negative 20. So can you give me two numbers that multiply together to get negative 20? Negative 2 and 10? Okay, so if we did, it's going to be too big. That one's not going to work. 5 and 4? How about plus? Let's just try one of them and see what happens. Plus 5 and minus 4. If you tried this one, what happens? 3x squared minus 12x plus 5x minus 20 equals 0. Well, we're just testing to see if it works actually. And is it close? Not really. Plus what? It's going to be minus what? Minus 7x minus 20. Is that what we want? No. So we're still here, right? We're not there. We're still right here. Yes, what's your question?
So the 5 and 94 is
No, it does not have to add up to 11. That only adds up to 11 if that is 1.
Okay, so then what?
Multiplies together to get negative 20.
Oh, okay.
That is the only thing for choosing. Yes, for choosing them when A is not 1. When A is not 1. Hold on, she's talking. Yes? The coefficient isn't 1.
Is not 1 in front of x. Then you solve for the third term. Two things that multiply.
And test, and test, and test, and test, and test. Yes. Yes. Okay, so first of all, we've tested one thing. So what else? Are there any other pairs we could try? Well, 3x, we could do 3x what? How about plus 4 and x minus what? 5 equals 0. Let's see if this works. Let's just test it. What do you get? 3x squared minus 15x plus 4x minus 20. Oh, look what you get. Does it work? Does it work? Yes, it does. So now what do you know? 3x plus 4 equals 0 or what? Or 3x plus 4 equals 0 from right there. Or exactly, x minus 5 equals 0. So what does that mean? X equals? Nope, looking at that one right there. Everybody, if you look up here. Yep, there you go. So 3x equals negative 4. So x is equal to negative 4/3. So if you write this out, you'd end up with negative 4/3, comma 5. So yes, it might be a little harder to factor at times, but you need to actually test. We ended up with one that didn't work, but then we got one that did work. Yay, it worked. This one. What's nice? The leading coefficient is 1. The leading coefficient is 1. Nope, there's no cubes in that. No cubes. I don't see any cubes. So now the difference, so the leading coefficient is 1, Rachel, so that means you're looking for two numbers that... Correct, and that's going to be x. What are those two numbers going to be? Negative 4 and 3. So you end up with x equals 4 or x equals negative 3. There it is, right there. There it is. Is it in standard form? No, put it in standard form. Once it's in standard form, factor it, and then break it apart into its pieces. Why do you have this? Because you know that x minus 4 equals 0, and x plus 3 is equal to 0. So that means that, and that means that. Another one, 33 is what you said, Deb? 33? So 33 is similar to one we just did. 2x plus 1 times x minus 3 equals 6x plus 3. Is this in standard form? Nope. So what do you have to do to the left here? What do we call that? FOIL? Yep. Can someone read off to me what you get when you FOIL this out? What does it become? 2x squared, yep. Yep. Yep, 6x plus 3. Is it in standard form? So subtract 6x, and you get a minus 12x plus x minus 3 equals 3. Oh, we can combine it. So 2x squared minus what? 11x? Minus what? We're going to subtract 3, so minus... is this in standard form? Is it in standard form? Yeah, it is. So now what do we need to do? We have to factor this, yes. Is the leading coefficient 1? Yep.
You did like 2x times negative 3 and got negative 6x plus 1.
Plus 1x, yes.
But then you didn't add.
I didn't add. I did it in a different order. I subtracted 6x like this, and then I was like, oh, there's that x. I forgot about that x. Yeah. No, that's fine. It was a non-standard way for me to write it down. Yes. So now it's the leading coefficient is what in this case? 2, which is not bad because it's 2 and just 1, right? So you need to break it apart. The two numbers need to multiply together to get what? Negative 6. How about minus 6 and positive 1? Does that work? Let's try it. Minus 12x plus x minus 6. Is that what we want it to be? It is what we want it to be. So therefore, what do we know? 2x plus 1 is equal to 0, or x minus 6 is equal to, so 2x equals 1, x equal, negative 1, negative a half, or x is equal to, so when you write the answer, you end up with negative 1/2, comma, 6. Yes, Nate? 3 by 3, there it is, Rourke, thank you. So can someone tell me how you rearrange that? What is the turn, Alyssa? Yep. And can you simplify each of those? Yeah, 5x squared minus 4x plus 2. Okay, so that's nice. It does simplify kind of nicely in some cases. Let's add a little bit of complexity here. So this is another single term in the denominator. This is another single term in the denominator. That's the key thing here. We have one term here and here. Similar breakup. Can you tell me what this breaks up into, Rachel?
5m squared over 5m to the second.
Yep.
Minus 9m to the second over 5m to the second plus 10m over 5m to the second.
Exactly. Correct. Now can you simplify that?
1m.
So just m, yep, exactly. Minus?
4.
Nope. That cancels, leaving you with what? 9 over 5. You can't subtract them. 9 over 5 is 9 over 5, not 4. It's okay. It's okay. Plus what?
Plus and 2m to the 3.
2 over what? Okay, kids. Let's do back to basic exponents. 10m over 5m squared is equal to 2 times 5 times m over 5 times m times m. What cancels? The 5s. So what are you left with? 2 over what? M. So this is equal to 2 over m right here. Okay. Was the system pretty much the same right here? Was the system pretty much the same? Yes. It was pretty much the same. So when there's a single term here, when there's a single term right here, you can break it apart into single divisions and do smaller single divisions. Is there always going to be a single term there? No, there isn't always going to be a single term there. So this one right here, let's say we didn't know factoring. Let's say we did this in 5.5 before factoring. Can someone tell me, if we use the same steps we just used, how many fractions can we break this into, Nate? How many did we get here? How many did we get here? So how many are we going to break it into? 3. It's going to be 2m squared over what? M minus 2. What's the next one going to be, Rachel? Over? Correct. Nothing changed. It's the same exact minus 10 over. Now here's the thing. Can you simplify these? How? You can't. This is subtraction, not multiplication. You know, yes, it is true, everybody. It is true that a times b over a, what does that equal? B, right. But what does this equal? What's a plus b over a? It's just a plus b over a. You cannot cancel. No, can't do that, right? The addition in the numerator makes it so you can't. Over here, can you cancel anything? No, you can't cancel anything. So you're kind of stuck. You are kind of stuck at this point. This would be fine. Those are equal expressions, but you can't simplify this any further. So let's go back to grade school. Let's say I asked you to do this. Let's say you did 1,294 divided by 12. How do you do that? No. How do you do that? What? Long division. Yes, Kelly?
Are you screen recording?
Yes, I am. Long division. That's fine. Long division. Right. So how do you do long division? You have to set it up first. How do you set this up? What is it? Yep. The little thing and? Exactly. So then you look at how many times does 12 go into 12? Once. And then once you write that 1 there, what do? You multiply first, and you get 12. And then what do you get? You subtract. What's left after you subtract 12? 0. And now you bring the 9 down. How many times does 12 go into 9? 0 times. You do 0 times 12 is 0. But what's 9 minus 0? And now what do you bring down? 4. How many times does 12 go into 94 without going over? How many times does 12 go? 7 times. So 7 is 70 plus 14 is 84. Now when you subtract, what do you get? 10. What is this called? This is the remainder. We have just shown, kids, this is important. We have just shown that 1,294, over 12 is equal to what?
107
plus 10 over 12. When you divide 1,294 divided by 12, you get 107, right? But then it's the remainder divided by what? 12, which is right there. Exactly. It's 107 and 10/12. This is long division. This is long division. So do this for me. Do 13 into 9,682. Do that by hand for me. Do that division by hand. What did you? Yep. Over 13? No, it's 744 plus what? Over. Who agrees with that?
Yes.
Who agrees with that? So let's do it out. Let's see if it actually works out here. So if you do this, 7 times 13 is what? 91. Now you subtract. You see those parentheses I put in? Those parentheses are going to be super important when you learn the next thing. When you subtract, what do you get, Kelly? Bring down the 8. Now, is it 4 now? So it's 52. Subtract and you get 2. So you then, what's it? Oh, it's still going to be 4, right? So what is it going to be? 52. So it's going to be 10. So the answer would be 744 and 10/13. Yes. Okay, so let's go back for a second here. I asked you this right here, correct? I said, how would you do this? And the problem is you can't just break it apart into 3 fractions, but could you turn this into a division problem? M minus 2 dividing into 2m squared plus m minus 10. This is called polynomial long division. The one phrase you need to take away from this class that is super important is this. Leading over leading. Love this phrase. What's the leading term right here, Calvin? What's the leading term? No, the whole term. What's the whole leading term? 2m squared is the leading term. What's the leading term right there? What is the leading term? No, m minus 2 is the whole thing. M is the leading term. What's 2m squared over m?
2m.
Yes, so then you put it up here. What do you do once you put your number up there? What's that one word? What do you do? You multiply it. You multiply it. You have to multiply first. And what do you get? What's 2m times m?
2m squared.
Yep. Yeah, exactly, Kelly. Now, when you subtract, what did I say you should put in there? Yeah, please put the parentheses in. This is by far. Watch. Everybody, hands up. Watch this. Do not write it down. You need to watch this. This is by far the most common mistake you make. Look at this. You are subtracting here. What is m minus negative 4m?
M plus m. M plus 4m.
No, just 5m.
Which is what? 5m. Bingo, you two. M minus 4m. Negative 4m. M minus negative 4m is 5m. Hands down. So what?
M minus negative 4,
M minus negative 4m. What's up here? What is m minus? Yeah, I'm sorry. I said it wrong. It's totally my fault. But now what do you get here? This cancels, right? So what are you left with? Oh, I did that wrong. Sorry. What are you left with? M minus negative 4m. 5m. I am. Okay, ready, everybody. Take the styluses, drop them. You're not allowed to pick them up for the next 5 minutes. Put it down. Try.
No, I won't do it.
Okay, then you're not going to absorb anything.
Wait, I have a question.
Kids, ready? I need you to go with me on it for a second here, okay? We're doing the exact same thing as long division. Exact same thing. So when we subtracted here, we did 2m squared minus 2m squared. What's that? 0. What's m minus negative 4m? 5m. What do we do now? What do we do now?
Hold on to negative 10.
Yeah. Now, what was the phrase? You can go back to writing. What was the phrase? Leading over leading. What's the new leading term here, Nate? Nope. So I just asked you for a sentence. Say the whole sentence. What is the leading term? Is correct. So say the whole sentence. Okay. Here, let me give you my perspective here. I asked you for a sentence. I said, what is the leading term? Someone said 5. Then someone said m. And then someone said the leading term is. Bingo! Oh, that's so good. 5m. And what's the leading term continue to be right there? No. Just m. Just m. It's okay. You're not. Don't be sorry.
I'm so sorry.
What's 5m over m, Hannah?
5m over m is
No. 5. So Kelly, when you write the 5 up there, what's that one word you do now? Yeah, you multiply now. So what do you get? Oh, look, and when you subtract, what do you get? So what does that mean the remainder is? The remainder is what? That right there is the remainder. Yay! So, no questions. Please, kids, you really have to stop talking while I and other people are speaking in this class. 2m squared plus m minus 10 over m minus 2. We just showed that equals what?
2m plus 5.
Yeah, we just showed it equals 2m plus 5, so it divides evenly. Pretty cool. We're actually pretty good at this. So, try this for me. Do this. Do x squared plus 5x plus 6 divided by x plus 2. Yes, you can pick up your stylus. So what do we get here? I think it's something like x plus 2 into... So what's the first leading over leading you have to do, Rachel? Over. Yeah, and what's that equal? Yeah, so you have x, and now you multiply. X squared plus what? X. Leading over leading. Okay, ready? Try it again. I guess I wasn't clear. What is the leading term of this? Squared is the leading term. X squared is the leading term. What's the leading term here? Leading term over leading term. That's what we just did right here. X squared over x. What is x squared over x? What is x squared over x? X. So now, once you have the x there, what do? Multiply each thing, yeah. X times x plus 2. That's correct, yeah. What is x times x? What's x times 2? So now you subtract. What's left?
3x.
Drop down the 6. What's the new leading term? The other one stayed the same. So what's 3x over x? So it's plus 3. What's 3 times x? Oh, 3x. When you subtract, what do you get? 0. So what did we say this equals? It equals? Yeah, there it is. Yay. Yay. So you set it up.
I know, but when 2 is the leading qualifier.
Okay, I understand. Kids, help me out here. What's the leading term, Katie? Squared. So what does it become? So now you multiply. 2x. Now I wrote to the 6. That's not correct. 2x squared plus. Yep. You bring it down. Yep. X over equals 1. Yeah. You end up with 1. Hold on. X. And it subtracts, and you get what? Is that a good thing? Yeah. So what does this equal? Yeah. Good job. We got the plus 1 at the end because the leading term here was, what was the leading term? X. And what does the leading term stay over here? What's x over x? 1 right there. Good job. Ready? 1, 2, 3. You did it. That was great. Someone lead me through it. So what's my first step in attacking this, Hannah?
Well, you write it in the long division form.
Yep, correct. Kids.
And then the repeating thing is under the thing.
The radical, yeah, the division sign.
Squared.
Yep, over.
And put that over the leading term
Yep.
on the outside, which is x.
Yep, and what does that equal?
Done. Isn't it just 3x?
Yes, exactly. Perfect. So someone tell me, what one word do we do next?
Multiply.
Multiply. 3x squared plus
6x.
Rachel.
Sorry, I'm talking.
I know you're talking. You subtract. What are you left with when you subtract now?
Negative 4x.
Negative 4x. What do you drop down?
Plus 17.
What's the leading term now?
Negative 4x.
Over x is going to be?
Negative 4.
So you have minus 4. You get minus 4x minus. Now when you subtract, got it. Can someone raise their hand and tell me what you get us? Rachel, what do you get? 21, right? Can you go any further?
No.
No. So the answer to this would be, ready? 3x minus 4 plus 21 over what? Perfect. The 21 is the remainder. Remainder. Right there. 13 minus negative 8. 13 minus negative 8. By far, the most common mistake on these is messing up subtraction, which is so sad because the rest of it theoretically should be the hard part. Just don't mess up the subtraction. Easiest thing to remember to do, see all these parentheses I'm putting in right here? Please put them in. Please put them in because you're subtracting. X plus 3. So we want to show 2x plus 1 times x plus 3 is equal to what? This thing on top, right? Oh, wait. Does this process look familiar? It looks like factoring. We'd have to FOIL it, right? If we factored, we could have done this a different way, but 5.5 is before factoring, so we're not doing it with factoring. But we'd FOIL this out, and what do you get? You do end up with that. So this one right here, how would you test this one right here? What do you multiply by? Plus 2. If you multiply this by x, let's just do this one so you can see it. If you multiply this, what happens when you multiply x plus 2 times this? What cancels? So this multiplied together equals what? Just 21, right? But also you have to multiply times this, right? So you know it's plus x plus 2 times 3x minus 4. You have to FOIL this, right? So you get 3x squared minus 4x plus 6x minus 8. 3x squared, what, plus how much x? 2x minus 8. But what do you have right here? 21, right? What's 21 minus 8? What's 21 minus 8? 3x squared plus 2x plus. Is that what we want it to be? It's right there, see? So see right there and right there. Same thing. That's how you would check it. But I'm not going to ask you to do that right now. Right now, kids, it doesn't matter what they throw at you. It can get a little ugly. Is it really nice when the remainder is 0? Is it always going to be 0? Don't freak out when you see weird things. Division is just division no matter what you throw at it. Okay, we're done.